So this is special segments in a circle. So we got 3 theorems, and the 3 theorems are going to describe how we can find the missing length. So the first one, we have 2 chords intersecting. Okay, so we got 2 chords, they're intersecting in a circle. The products of the measures of the segments of the chords are equal. So the chords are going to split each other off. They're going to break each other off into segments. Then we just find their products, and those should be equal. So for example, here's 2 chords in this diagram of circle O. We have A, B, C, and D. So we would take AB, and that should equal CD. So let's say I tell you, let's see, C can be 10, D can be 3, and A can be 6. We want to find B. We go, okay. Well, 6 times our B, because those 2 are on the same line, should equal 10 times our 3. So that's 30. So 6B is 30, so B would be 5. Okay. So when we're intersecting inside like that, when we have the 2 chords, just look at their products.
So it's kind of like cross multiply.
Not really. No, it's the products are from the same line. So notice 10 and 3 are on the same line, so we want to take 10 times 3. And 6 and B are on the same line, so you would take equal to 6B. Okay, so the next one is dealing with secants. So if 2 secant segments are drawn to a circle from an exterior point, the product of the measures of one secant and its external segment is equal to the product of the measure of the other secant and its external segment. Well, let's try to decipher what that's saying. So what do you think when it says the measure of the secant is talking about? Is it talking about the length of the whole line, just part of the line? The whole secant is its entire line. The external secant is a part of the line that's on the outside. Okay? So here, AB and AD, those would be the external secants because they're outside of the circle. Okay? Whereas AC and AE would be the whole entire secants. So what you do when you want to find these is you have to take the whole length times the piece outside should equal the whole length times the piece outside. So let's say this is 10, that's 7. And that's the whole length here is 20. We want to find what the piece outside is. Okay? So you would have to take the entire length times just the segment outside. So for the line that we know everything about, what would be the entire length? 17 times what's just the external? 7. We'd make that equal to, for the other one, what's the entire length? 20, and just the piece outside is x. So then what's 17 times 7? 100 and what?
19.
Okay, 119 is equal to 20x. Divide by 20. 5.95. So that's your value for x. Okay, and the third theorem is actually very similar to this, except for this time we have a tangent and a secant. So here, if we have a tangent and a secant are drawn from a point to on the exterior, the square of the measure of the tangent is equal to the product of the secant and its external segment. I actually like to view this one just the same as the previous one. The difference here is the tangent, the exterior part, is the same as its entire length. So you're going to have to multiply that one by itself.
What's the difference from a tangent and a secant?
Tangent just touches the circle one time. A secant will touch the circle twice. So let's say DC is 9 and AC is 4. We want to find AB, our x. Okay, so let's look at the secant line. What's the entire length of the secant line? 13 times, what's just the external part? 4. Should equal x times x, because the entire length of the tangent and the part outside are the same. So it's equal to x times x. X squared, yep. So 13 times 4 is 52 is equal to x squared, and then how would you get your x? Square root it. So square root of 52. So x here is about 7.2. Yep. All right, so now let's go through and let's do some more examples using this. Okay, so for first one, we are intersecting inside of the circle. Okay, so we would take 3 times 8. Okay, equals 6x. So 24 is equal to 6x, so x is 4. Okay, how about number 2? Ooh, not 10 times 2. Common mistake, though. 10 here is only talking about what? Just the radius. So what's the additional length? So that's 8. So this would really be 18. So you would take 18 times 2. Okay, so 18 times 2 should equal what? Well, you're right. That is 36. But what should that equal? What's our other segment? X squared. Yep. Yeah, so x is 6. Does anyone see another way how you could have solved this one? Yeah, you could have Pythagorean theorem. Here you could have drew a radius in over here of 10. You have that side as 8. And you could have did it a squared plus b squared equals c squared to find your x. That also would have worked. Okay, how about this next one? Okay, so 6 times 5 is equal to 6x squared. Yep, 3x times 2x would be 6x squared. Yep, 30 is equal to 6x squared. So 5 is equal to x squared. Square root of 5 is 2.2. Is that okay? All right, how about number 4? Sure, we can do it that way. Well, let's do it this way first. It'll be good for us. So it's 5 times 5. 25. X plus 2 times x plus 2. We'll have to FOIL.
So it'd be x squared plus 4.
4x plus 4. We did the outside, inside step in our heads. We did outside was 2x, inside was 2x. I see some looks that said, Miss Burns, what the heck did you just do? So I'll write it out again here. A few more steps. You have to distribute the x to both of them. So x times x is x squared. X times 2 is 2x. Now do the same with the 2. 2 times x is 2x. 2 times 2 is 4. 2x and 2x gave us our 4x. When we have a quadratic, how do we have to solve this? What does this have to be equal to? It's got to be equal to 0, so we have to minus the 25. So then we have 0, x squared plus 4x minus. And then factor that out. So let's see, factors of 21, that would subtract to give you 4, plus 7 and, so what are the two answers that x could be? Negative 7 or a positive 3. Which one makes more sense for lines? Positive 3. Does anyone see the easier way to do this now?
No, but calculate.
Yeah, 5. X plus 2 equals 5.
What point is this going through? The center? So are these all radii? Yeah? So couldn't we just have said x plus 2 equals 5?
Yeah.
Okay, either way, we get x equals 3, right? No, that's actually good. We're going to have to use that later, so it's good we refreshed it now. Oh, yeah. Number 5. So now we're dealing with outside. So anytime we're intersecting outside the line, we need to take the whole length times just the portion outside. Okay? So for 5, what would we have here? It's not 15 times x. 15 is the length outside, but what would be the whole length? Yep, so we'd have to say 15 plus x. And then times what's the length outside? 15. Equals the whole length of AB is 18 and the length outside is 18. So 18 times 18. Well, what's 18 times 18? There's two ways that you could solve this. One way is you could certainly distribute the 15. What's another way that might make it a little bit? Could we just divide by 15?
Yeah.
So let's just divide by 15 here. So then we have 15 plus x is equal to 324 divided by 15. What is that? $20 what?
21.
And then how would we get our x alone? Minus the 15. So x is? What is it? 6.6. We certainly could have, call it red, there we go. We certainly could have distributed this, and then we would have had 225 plus 15x is equal to 324, then subtracted our 225, and then divided by 15, we would have still got the same answer. Okay? So it doesn't matter which way you think about it. It's just if you divide by 15 here, you are you don't have to do the distributing step. Okay? All right, how are we going to set up 6? Okay, so 18 plus x times 18, yep. 16 plus 26 times 16. Okay, so what's 16 plus 26? What is it? 42. So we have 42 times 16. What is that? 672. So now we have 672 equals 18 plus x times 18. So divide by 18. 18 plus x is equal to 37.3. Subtract 18, so what's x? 19.3. Is that okay? Yep, that's what 672 divided by 18 was 37.3. Good? All right, let's look at this one, number 7. Okay, so this first one here would be 6 plus 4x times what? Times 6 is equal to? Times 6. What can we do?
One on the right, can you make it 9 plus?
Okay, so let's make it to 9 plus x. That's good. And then what? We can distribute, certainly. Is there something else we could do here? Try to think smart mathematically. Why can we cross off the 6's? If we divide both sides by 6, they would cancel. So we have 6 plus 4x is equal to 9 plus x.
Then you subtract x.
And subtract the 6. So we have 3x is equal to, so x is 1. Okay, how about the next one?
5 plus 15.
No, not 5 plus 15. Not 15 minus 5, nope. Look carefully at where the 15 is labeled. Yeah, 15 is not the whole way across the circle, it's just the radius. So we'd have to do, what would be the whole way across the circle? 30, yeah. So this would be, yeah, so that whole way would be 30. So we'd really have 30 plus 5, which is 35 times what? 5, what should that be equal to? X what? X squared. Yep, x times x, so x squared. All right, 5 times 35? 175 is equal to x squared. Square root, so x is equal to? 13.2. Is that okay? We do not do one other type of problem, which we do need to do. Just going to make sure I grab one that I'm not assigning you. See, I'm assigning you that one, so that one won't work. We'll do this one. There's my beautiful circle. Whoop, I did that the wrong way around. Undo, undo. You can all tell I write my 5s in 2 different segments, I see. X should be here and 5 should be there. And then 15 and 6. Okay, how are we going to set this one up? Okay, so 21 is 15 plus 6 times what? 6 is equal to, not 5x, 5 plus x times x. 6 times 21? 126 is equal to, now will we just be able to divide by x? Nope, that won't work. So what will we have to do with this x? Distribute. So we will have 5x plus x squared. Ooh, we have a square. So we have to subtract the 126 to get it equal to 0. And we want to write it so that x squared comes first. So x squared plus 5x minus 126. Factors of 126, and we want it to subtract to give you 5. Factors of 126. I'll give you the first one. 1 times 126.
Oh, thanks.
You're welcome. 2 times what? 63. Will 3 fit in there too? 3 times 42. None of these will subtract to give us 5 yet, though. Will 4 go in there? No. How about 5? 6? 6 and 21? Still doesn't work. 7? 8? 9? 9 times? Ooh, this one works, right? This subtracts to give you 5. So we would factor this then to plus 14 and x minus 9. So what are the two values for x here? Negative 14 and positive 9. Which one makes sense to be a side? Positive 9, so x is equal to 9. There you go. I made sure I did one of the harder problems with you as well. Okay, so there will be ones with that involve you having to factor. Okay? Factoring is essential, especially when you get to Algebra 2 next year. How do we know what? Because that was our middle number, so we want it to multiply to give you the last number. And then if this has a minus sign, that means we want to subtract to give you the 5. So if this had like 15 instead, this would have been your solution, the 6 and the 21.